Good morning, guys. Today our topic is trigonometric Fourier series. We can express our Fourier series in trigonometric way. Okay, so this is desired metric Fourier series. Okay. So that is actually the formula of this particular parameter functions. Okay, so the percentage of dependability that will be considered as the number of the corrected whether the okay. So any Fourier series, any series can be expressed in the sinusoidal term. That is, that is function of t, that is any function. It is a periodic function. First of all, it is a periodic function. It may be expressed as a naught, that is a coefficient, then a1 cos omega naught t plus b1 sine omega naught t. Okay. Again, nth harmonics means this is first harmonics. Then this is a2 cos 2 omega naught t. This is second harmonic plus b2 sine 2 omega naught t. This portion, and you may go up to the nth order. I may see, write down this is a cos 3 omega naught t plus b3 sine 3 omega naught t. Okay, in this way we can write down up to the nth order. So in this equation you can see this portion is called the DC component. This portion is called DC component. And this portion is called the AC component. Okay. In this Fourier series. So if we go for the summarization, and what is the omega? Omega naught is the fundamental frequency, that is 2 pi by t, 2 pi by t, and that is called radian per second. Okay. And if I go for the summarization, we find it, that is function of t, that is a naught. This set a naught is there, and we have to summarize this. So summation of n equal to 1 to the infinity, and that is an, because a1 2 3 4, that is an. A is connected with this cos omega naught t, and here you have to write this n. This n means this is the n time. If this is n equal to 1, this is first harmonics. If this is n equal to 2, then this is second harmonics. Okay. And then bn sine n omega naught t. So what is harmonics? See, as per the Fourier series, is any periodic signal could be expressed in the infinite sum of sinusoidal signal. So say this is your square wave, this is your square wave. It could be expressed in this way, that is first one sine wave, this is first harmonics. It could be expressed in, if this is a second, two signals is there, then it would be a second harmonics. If there is a three signals is there, three side, then this is called third harmonics, because three signals are there. If you put some much signal over this here, infinite sum, it is seems like, it is looks like your this. And if this is, whenever infinite harmonics are there, then it looks like a square wave. Okay. So this is your trigonometric expression of this Fourier series, but it has some properties. Now this is called the DC components, and this sine n omega naught t cos n omega naught t is called the nth order harmonics, and a0 an bn is called Fourier coefficient. This an and bn, where for n not equal to 0. Okay, and it is the amplitudes of the sinusoid. An and bn is the amplitudes of the sinusoid. Okay, this is for the sine, this is for the sine, and if this is a cosine, then cosine, then this is for the b, this is the an, and this is the bn. Bn for sine, an for the cosine. Okay, so thus the Fourier series, okay, so we can say that the smaller series of a periodic function of t is a representation of, and it represents of that, sorry, of that the sensitivity of any such kind of reading, so that it will detect the smallest possible fault. Of that resolve function of t into a DC component as well as AC components. DC components as well as AC components. So if any such kind of fault that will appear very hugely and comprising on infinite series of harmonics, that the sensitivity of instant system has to be increased. We cannot improve if any such kind of major fault that appears in the system. But in any such kind of minor fault that appear in the system, which will be series of harmonics. Okay, so for that cases, we have to classify or we have to characterize the fault so that we have to improve the sensitivity of the particular relay system. Harmonic sinusoidal fault that will involve zero sequence. Okay, for example, okay. I will show that. For example, so we have to know some identities by which we can perform this. That is, if I take a integration on over one period, and no, from this equation we have to find out, we have to find if a sequence or a series is given, then we have to find out what is the a naught, what is the an, and what is the bn. Then we can easily express any signal, any periodic signal into a Fourier series signal. Okay, so our aim is to find out the a naught, an, and bn. So we will do how it is possible. Just that's why we need to we need to know some identities, that is 0 to t. This is a formula, just like a formula. We have to remember this: sine n omega naught t dt equal to 0. Just remember, this is the a. Okay, and this is 0 to t, that is cos n omega naught t dt, that is 0. Just remember this, 0 t, that is sine n omega naught t multiplied with cos m omega naught t dt equal to 0. That is C. Okay. Given, look, sine n and m, it may be n and m equal to equal, it may be m and n not equal. Okay. Now, if I write both sine n omega naught t sine m omega naught t dt equal to 0. This is C, that is D, where m not equal to n. Okay. Then we can write cos n omega naught t cos m omega naught t, okay, dt equal to 0 CDE, that is m not equal to n. Okay. And now t cos n omega naught t cos m omega naught t, sorry, this is dt, sorry, it has been repeated, not required. Look, this is sine square in omega naught t dt equal to t by 2 cos square in omega naught t this is t by 2. Okay. F G. Just remember these things and we will apply to find out the A0, AN and BN. So just find out our fundamental equation is just function of x equal to, sorry, this is a continuous function. You may write here that is t. You may write here that is t a naught. This is your DC function. Okay. Summation of n equal to 1. Why I am not taking minus infinity? Because this is a periodic signal. So periodic signal, in this part, whatever is there, here is also the same part. So I am taking from here. Okay. Or you may take from 0 also. But here n equal to 1 because harmonics is given. And an cos n omega naught t plus bn sin n omega naught t. Okay. So we have to find out a naught, we have to find out an, we have to find out bn. So first we have to create some we have to find out the formula how to find a naught bn and a naught an and bn. First step one, find out a naught. Okay. So to find out this a naught, we have to integral at the both side. So what happens if we integral for one period? Okay, one time period, we have to make it integral. So integrate both side. Okay, so function of t, it is integrated, that is dt. Function of this t for one period, that is coming a naught plus summation of n equal to 1 to the infinity an cos n omega naught t plus bn sin n omega naught t dt. Now if we have to break it, if we break it, then we get a naught that is dt, plus this summation will be going outside, integration, that is, I just make it third bracket. Sorry, this is an cos in omega naught t. I'm going step by step so that you can understand. Dt plus again 0 to t, 0 to t for one period time, bn sine in omega naught t dt, just going on. Guys, for this new slide, you can write down. Then I'm going for the new slide. Now we have just remembered this thing, integration of one period identities. First A and B. A and B, if we put this, then sine in omega naught t dt equal to 0. That is A. Just remember this thing. So I can put it integration 0 to t A dt. It was first, then we get all this part, this sine part and this cos part became 0. Just remember these things. Here is some summation, that is up to infinity n equal to 1. That is a n sine n omega naught t. These things dt, this becomes 0. And these things, it is also become 0. bn cos n omega naught t. This is also 0 for the second identities, dt's, that is 0. So only this portion is remaining. So we can write integration 0 to t function of t dt equal to integration t a dt. Here we can write this. If we integrate this, look, a naught, actually this a naught is coming, and if you go for only dt, integration over dt, so only t minus t0, so a naught t is coming. So ultimately this portion is became this. So I need to find out this portion. So just keep it and make it, this is coming over here. So this is 1 by t. So this is 1 by t function of t, function of integration over this 0 to t and dt. So actually a naught is the average components of this function of t. Why this is called average? Because you know, from 0 to t, say 0 to t, the what is the value? What will be the value? It will divided by this t. So this is become a integration 0 to t. This is integration. So what will be the value? Say 1, 2, 3, 4, 5. It is integrate, means it is addition and then divided by total time period. So it's became a average value. So we can just write down. So A naught is the average value of function of t, because this is the average. This is integration. Integration means summation and then divided by t total. So this is became just average value. Okay. So second step is to find out. Step 2, find out the an, this. Okay, so just write down the fundamental equation, that is function of t equal to a naught plus summation of n equal to 1 to infinity, and that is an is concerned with this cos value. So cos, yes, this is cos in omega naught t plus bn is concerned with the sine value. So sine in n is always there, then omega naught t, that is the fundamental equation for the Fourier series. Now to find out these things, we have to find out this an. So we have to multiply it with cos n cos n m omega t and integrate. Integrate and integrate over 0 to t and multiplied with cos m omega t, omega naught t. Okay, so what happens if I do this? Then we got both side, for the both side, because we have to do both side. There is nothing to say. This is 0 to t function of t into cos m omega naught t dt equal to, this is also 0 to t a naught cos m omega naught t plus summation n equal to 1 infinity, just integrate over there. Look, you have to multiply it. Okay, so an cos in omega naught t multiplied with this portion. So that is cos m omega naught t, and this is under third bracket because sine part is also there. So this is 0 to t, that is bn sine in omega naught t multiplied with this portion, that is, sorry, not plus over here, this is multiplication. Oh, this is t, not plus. This is in omega naught t, and this is cos m omega naught t dt. Okay, up to this. Now we have to think about it. Look, sine n omega naught t and cos m omega naught t dt and integration over 0 to t, it is actually giving you the 0. Okay, this is also giving you the 0 if n not equal to m, but it is gives some value if n equal to m. And this portion also 0, because in previous cases you have seen anything cos m omega t 0 to t, this is identity is 2, means identity is b, it is also 0. So this portion is remaining over here. So this portion is remaining over there, that is integration 0 to t a naught cos m omega, you know this is 0, but if this is 1, then this is not 0. Condition is there, if there is n not equal to 1, then it is 0, but if m equal to n, then this is not equal to 0. So what happens if I get this? So just write down 0 to t integration a naught cos m omega naught t plus cos cos n omega naught t m omega naught t. So n equal to m. So this became cos square. Sorry, this is bn. Sorry, cos is concerned is an. Sorry, cos is concerned with an, not bn. B is concerned with sine. An cos square. You put m equal to n. So here you can put n. Cos square n omega naught t dt. So you know the value is that is t by 2. You know the value is that is t by 2. So you can easily put this value over here, that is integration 0 to 2. That is let LHS part. Okay. It was multiplied with cos m omega naught t, or you can say that is n omega naught t, because this is equal m equal to n. So it is equal to t by 2, this portion. So my aim is to find out this portion. This is, so if this is here, we can find from this portion Just keep it. Just keep it. So a n equal to this 2 by t is became 2 by t integration 0 to t function of t. Sorry, here this portion was coming out, that is a n. M or n, whatever you may write, m or n. Okay, because m and n are equal. So this m omega naught t dt. Okay, so this is your n. Similarly, if we want to uh, calculate the bn, step 3, if we want to derive the bn, then just do the same, but integrate over 0 to t and multiplied with multiplied with this sine m omega naught t. Then in this way you can find, that is 0 to t function of t sine m or n, whatever you may write, omega naught t dt, omega naught t dt equal to bn t by 2, bn t by 2, and this will give you, this will just coming here, so it will giving you this bn equal to this became coming here. So this is 2 by t integration 0 to t function of t sine m or n omega naught t dt. So from this equation we can find, that is bn. Okay. Okay, now second step is to find out the amplitude and phase form. Amplitude and its phase. So function of t could be written as a naught plus summation of n equal to 1 to infinity e n cos, this is a phase formation, okay, omega naught t plus phi n. Okay, so we know if there is a cos alpha plus beta is there, then the formula is cos alpha cos beta minus sin alpha sin beta. Okay, this is your normal conventional formula. Okay, so if we split this portion, then we can find function of t, it is a naught plus summation of n equal to 1, and that is a n cos phi n. You just make a bracket. Okay, first time don't make bracket because then you can't understand. Okay, then second time we will go for the bracket. This is cos a cos b, cos alpha cos beta, or you make cos phi n, and this is cos n omega t, cos n omega not t. This portion, this is cos alpha, this is beta, or you may say this is beta, this is alpha. and this is minus a n sine phi n and sorry sine n omega t, sine n omega naught t. Okay, this is your equation, just split it. Now if you just remember the fundamental equation, I again repeat this fundamental equation, that is a naught plus summation of n equal to 1 infinity a n cos n omega naught t plus b n sine omega naught t. This is your fundamental Fourier series. Okay, so if we compare these two equation, we can find that is this portion and this portion is same. Okay, so an is this portion, so an is this portion, and similarly this portion and this portion is same. Sine omega naught t, sine n omega naught t, here is sine n omega naught t. Okay, so only this portion is same and this is total. So we can write a naught equal to a naught means same, and a n equal to a n cos phi n. Here we can write this b n equal to minus of a n sine phi n. Okay, this portion and this portion are equal. So our intention is to find the a naught, a n and b n. This is called Fourier analysis. Okay, so from this equation, we can find what is the value modulus of this an. An is root over of an square plus bn square. And what is the phase angle? This is became minus, this is minus tan inverse bn by an. Okay, so this is an equal to phi n equal to an minus jbn. Okay, this is your formula. And now we have to plot it. We have to plot in this way. So you can write down. So guys, I think you can understand what is the phase form, phase and amplitude form. Okay, so amplitude an of the harmonics such in omega naught t is called the amplitude spectrum. Okay, and phi n versus in omega naught t is the phase spectrum. Okay, both amplitude and phase spectrum from the frequency spectrum of this function of t. Okay, so you can write the frequency spectrum of a signal consists of the plots of the amplitudes and phase of the harmonics versus frequency. Okay. So guys, this is the representation of continuous system in trigonometric expression. This is your Fourier expression. And next class, I will give you an example so that you can understand any signal. Say there is any signal, say this is a square wave. This square wave could be, it may be expressed in the Fourier series. Okay. It may be expressed in the Fourier series by mathematically and by graphically. So the statement is then you can realize how any periodic signal could be expressed in infinite summation of sinusoidal signal. This is a square wave, but if you go for nth harmonic order, if you go for nth harmonic orders, then within this time period, this signal looks like a square wave. Okay, but actually it is a sine wave. First sine wave, this is the second sine wave, this is second harmonic sine wave. Within this period, two wave are there. If there is a three, then infinite time, then it became a square wave in this way. So guys, if you have any question, you may ask me. Otherwise, I am going to stop over here. Thank you. Have a nice day.